All right, let's see if we can find the indefinite integral of 1 over 5x squared minus 30x plus 65 dx. Pause this video and see if you can figure it out. All right, so this is going to be an interesting one. It'll be a little bit hairy, but we're going to work through it together. So immediately, you might try multiple integration techniques and be hitting some walls. And what we're going to do here is actually try to complete the square in this denominator right over here. And then by completing the square, we're going to get in the form that it looks like the derivative of arctan. And if that's a big hint to you, once again, pause the video and try to move forward. All right, now let's do this together. So I'm just going to try to simplify this denominator so that my coefficient on my x squared term is a 1. And so I can just factor a 5 out of the denominator. And if I did that, then this integral will become 1/5 times the integral of 1 over, so I factored a 5 out of the denominator. So it is x squared minus 6x plus 13 dx. And then, as I mentioned, I'm going to complete the square down here. So let me rewrite it. So this is equal to 1/5 times the integral of 1 over, and so x squared minus 6x. It's clearly not a perfect square the way it's written. Let me write this plus 13 out here. Now, what could I add, and then I'm going to have to subtract if I don't want to change the value of the denominator, in order to make this part right over here a perfect square? Well, we've done this before. You take half of your coefficient here, which is -3, and you square that. So you want to add a 9 here. But if you add a 9, then you have to subtract a 9 as well. And so this part is going to be x minus 3 squared. And then this part right over here is going to be equal to a positive 4. And we, of course, don't want to forget our dx out here. And so let me write it in this form. So this is going to be equal to 1/5 times the integral of 1 over, get myself some space, x minus 3 squared plus 4, which could also write as plus 2 squared. Actually, let me do it that way. Plus 2 squared dx. Now, many of y'all might already be saying, hey, this looks a lot like arctangent, but I'm going to try to simplify it even more so it becomes very clear that it looks like arctangent is going to be involved. I'm actually going to do some u substitution in order to do it. So the first thing I'm going to do is let's factor a 4 out of the denominator here. So if we do that, then this is going to become 1/5 times 1/4, which is going to be 1/20 times the integral of 1 over x minus 3 squared over 2 squared. And then this is going to be a plus 1. And of course, we have our dx. And then we could write this as, and I'm trying to just do every step here. A lot of these you might have been able to do in your head. 1 over, and I'll just write this as x minus 3 over 2 squared plus 1, and then dx. And now the u substitution is pretty clear. I am just going to make the substitution that u is equal to x minus 3 over 2. Or we could even say that's u is equal to 1/2 x minus 3/2. That's just x minus 3 over 2. And du is going to be equal to 1/2 dx. And so what I can do here is, actually let me start to re-engineer this integral a little bit so that we see a 1/2 here. So if I make this a 1/2 and then I multiply the outside by 2, so I divide by 2, multiply by 2 is one way to think about it. This becomes 1/10. And so doing my u substitution, I get 1/10, that's that 1/10 there, times the integral of, well, I have 1/2 dx right over here, which is the same thing as du. So I could put the du either in the numerator, I could put it out here. And then I have 1 over, this is u squared plus 1. Now you might immediately recognize, what's the derivative of arctan of u? Well, that would be 1 over u squared plus 1. So this is going to be equal to 1/10 times the arctangent of u. And of course, we can't forget our big constant c because we're taking an indefinite integral. And now we just want to do the reverse substitution. We know that u is equal to this business right over here, so we deserve a little bit of a drum roll. This is going to be equal to 1/10 times the arc tangent of u. Well, u is just x minus 3 over 2, which could also be written like this. So arctan of x minus 3 over 2, and then plus c. And we are done.